Okay, getting back to C for a few topics. We're going to talk about flow control in C to start with. So most of this should be reviewed just from your understanding of Java and probably from some of the programs you've already written in C. But we'll just sort of quickly go over everything just to make sure everyone is on the same page. And along the way, we'll point out differences in how C differs in some cases from Java and other languages. So we'll talk about the compound statement again, just briefly. We'll look at the if statement, for loops, while loops, do while loops, the break and continue statements, switch statement, and then the eval goto. So we talked already about compound statements in topic 5. It's just a fancy way of saying you can put a bunch of statements in braces and call that a statement. So the C compiler will treat any statements you put in braces as a single statement. And we call that the compound statement. Again, we talked about the fact that the compound statement does not end with semicolons. It's the same as in Java, right? If you have a function body with a bunch of statements in braces, you don't put a semicolon at the end of those braces. So the reason why we talk about the compound statement is that almost all of these statements that we're going to talk about in this section, the C spec, like for example, an if statement. The body of an if statement, the C specification says it takes a statement. So what that means is we can either provide one statement, or if we want multiple statements in the body of our if statement, then we use the compound statement. Starting with the if statement, I think we're familiar with the notion of if. It's used to conditionally execute code based on a given expression. Now, where it differs from Java in C is that Java will execute the body of the if statement if the value of the expression is true. In C, the body of the if statement is executed if the expression is non-zero. Okay, so if it's 1, if it's 2, if it's -1, then it will execute the body of the if statement. Otherwise, if it is 0, then it will be skipped. Okay, so we've got 3 forms here. We've got just the simple if statement, so we test an expression. If it is non-zero, then we will execute the statement on line 2. If it is 0, then we skip past and we execute the next statement on line 4. If else, same idea here. If it's non-zero, execute statement 1. Otherwise, if the expression is 0, then we execute statement 2. In either case, we move on and we execute the next statement on line 10. And then form 3, again, if else. You guys have probably seen this. We test expression 1. If it's non-zero, execute statement 1. Otherwise, test expression 2. If it's non-zero, execute statement 2. Otherwise, execute statement 3. And then proceed with the next statement. Okay, so just a very simple example here. Line 4 and 5, we're prompting the user to enter 2 numbers. And then we just have an if else statement that tests, are the 2 numbers equal? If so, we print a message saying they're equal. Otherwise, we check, is one greater than the other? Print a message. Otherwise, we say, okay, it's less than the other. Just to point out here that, strictly speaking, the C compiler does not require the compound statements for any of these if and else bodies. So I don't need to have braces around those printf statements. We did say, though, in topic 5 that we are going to require them for this course because arguably they add clarity, right? They sort of add a little bit of white space. They break up your code a little bit, make it a little bit more readable rather than having it all dense and tersely packed in. They also make it easier to add additional statements to a given clause. So if I realized, oh, okay, I want to do something else in this else if clause, then I can just quickly insert that. The braces are already there for me. And then finally, they also avoid certain bugs like the dangling else problem. So dangling else is a common bug where you can see by the indentation here that it appears that the author is intending that else to be attached to the outer if statement, right? If expression 1, else, run statement 2. So based on the indentation, that was what they were intending. But really, because there are no braces there, that else is going to be attached to the inner if statement, and that's probably not what the author intended. So we can get rid of a bug like that by just simply putting braces around everything. Okay, for loops, arguably the most important loop. they are pre-tested loops, so they may execute 0 or more times. Again, I think we're all familiar with for loops, but just to quickly go through it, we will execute the initializer expression first. So this is generally going to be, int I equals 0, or initializing some sort of counter variable. We then evaluate the conditional expression. So is I less than 10 or something like that? It's usually going to be a relational expression. If that is 0, so if that evaluates to 0, if it's false, then we do not execute the loop. And that's why we say it's pre-tested and it may be executed 0 or more times. So if the expression is 0, we fall out of the loop. Otherwise, we'll execute the statement. And then at the end of each iteration, we will execute the loop expression, which is usually going to be something like I++, some sort of increment. And then we continue on and we evaluate the conditional expression again. Is I still less than 10? If so, execute the body of the loop. If not, continue with the next statement. Okay, so just a few examples of what we can do with for. So line 8 there is just a simple for loop counting from 1 to 20. On line 14, we can, of course, count downwards if we want to. So we start at 100 in that case. We keep going while the count is greater than 0. And each time we are going to decrement the counter instead of incrementing. We don't have to increment or decrement by ones. So on line 21, we are incrementing each iteration by 5. So counting by 5s. The initializer expression is also optional. So you can see on line 28, I do not have anything in the initializer expression. Instead, if we've already initialized the variable outside of the loop, that's fine. You just put a semicolon there and you put nothing in that expression. And indeed, very little needs to be in the for loop. So in this case, we have omitted the initializer expression. We've also omitted the loop expression. So if I'm updating the, whatever my condition is, I can update it right in the loop itself. And then I don't need that loop expression if I don't want it. And in fact, we don't even need the condition. If I take out the condition, it just becomes an infinite loop, which can be useful in some cases. And then finally, on line 44, we're using the comma operator to both initialize multiple variables in the initializer expression. So I'm initializing x and y. And in the loop expression, I'm incrementing x and decrementing y. So we call that the comma operator. Okay, and of course we can nest for loops or any other statement within a for loop. So in this example, we've got an outer for loop that's iterating over a set of rows. We've got an inner loop that's iterating over a set of columns, and then we're just printing out a block of x's. Okay, so the while statement, another pre-tested loop that may be executed 0 or more times. So again, I think we're all familiar with this, but we test at the start before we execute the body of the loop. Is the conditional expression, is it non-zero? If so, we execute the statement and then we go back up and evaluate that conditional expression again. If it evaluates to 0, then we're done and we continue with the next statement after the loop. So this is just saying that the for and the while can be rewritten as one another. So I can write a for loop as a while loop and vice versa. So if I just have a for loop, I omit the initializer expression and the loop expression, that's the same as a while loop, right? It's just testing a condition on every iteration. These two are also equivalent. So if I've got my standard for loop, it's equivalent to this, where I initialize whatever variables I need to initialize before the loop. I then test my condition in the conditional expression. And then I execute my statement. After my statement or statements have been executed, I run my loop expression to update my counter variables. Simple example here of a while loop. So we ask the user to enter 2 integers. We're running the Euclidean algorithm to compute the greatest common divisor. So while b is not equal to 0, we divide a divided by b, and we take the remainder, assign that to b. A becomes the previous value of b. We keep going until b reaches 0. And then eventually we print out the greatest common divisor. Okay, so do while. This is a post-tested loop instead of pre-tested. So it gets tested after each iteration of the loop, and therefore it will be executed at least one time, so one or more times. So we have do, we execute all of our statements, and then at the end of each iteration, we will check if the conditional expression is still non-zero. If it is, then we loop back around. If it's not, then we fall out of the loop. So this is often going to be useful for this sort of thing where you want to prompt a user, you want to make sure you print your prompt at least once, and then if they enter invalid input, then we want to loop back around and re-prompt them. But if their input was valid, then we want to fall out of the loop. Okay, so lines 9 to 12, we're printing out a menu. Line 15, we then prompt them. And while their choice is invalid, while it's less than 1 or it's greater than 4, then we're going to loop back around, we're going to print that menu back out again, and we're going to re-prompt them. But if they enter a valid choice, then we fall out of the loop and we return it. And then same idea here. So we are calling that prompt user function within a do while loop, and we're saying while their choice is not equal to 4, while it's not equal to quit, then we're going to keep going. So we loop back around, we prompt them again, and then we just print out what they chose in this case. When they eventually select 4, then we fall out of the loop and we return out of our program. Okay, so here I enter 1. It says you chose 1. Choice is not equal to 4, so it loops back around, re-prompts them. This time they enter 9, so that is going to loop back around because their choice is greater than 4, re-prompts them, and then finally they enter 4. That gets returned from there. While choice is not equal to 4, well, it is equal to 4 now, and so we exit the program. Okay, so break and continue statement. So the break statement is used to exit a loop immediately, which is going to be useful when we have certain conditions that we are not necessarily testing in the loop condition, but we still want to be able to terminate our loop immediately. So in this case, we've got an infinite loop on line 3 here. We're saying while 1, so while true, we're prompting the user for a choice, and once they enter Q, then we say break on line 10, which is going to break them out of that loop. Continue. So continue skips to the next iteration of the loop. So it's useful when you've got some kind of condition that you don't want to execute all of the statements in the remainder of the loop body. You just want to go to the next iteration immediately. So in that case, you're going to do continue. So in this case here, I'm looping I is 0, I is less than 1,000, and I say if the next integer is even, right? If I mod 2 is 0, then we're going to continue. We are not going to execute this printf statement. We're going to continue on, increment I, and go to the next iteration of the loop. Otherwise, we'll print out the value, in which case we end up printing out only odd integers. Okay, so here's an example of a program where we're playing a game of high-low, where the computer guesses a random number. So first of all, we seed the random number generator, okay, and we're seeding it with the current time, which basically we're initializing the random number generator. If you do not do this, and you call the rand function to get a random integer, you'll get the same integers every time, the same sequence. So you have to seed the random number generator. So we start off by doing that. We generate a random number between 1 and 100, and then we go into an infinite loop here. And we ask the user for a guess between 1 and 100. And we're saying here, okay, so we're calling scanf, we're asking for an integer. And we're saying if it's not equal to 1, so scanf is going to return the number of elements in this format string that were successfully matched. So if it did not successfully match an integer from the user's input, then we're going to call this clear input stream function, and we're going to continue. We're going to go to the next iteration of the loop and re-prompt them. So let's look at clear input stream. What this is doing, so here's an example of a while loop where we don't actually do anything in the body of the while loop. Everything is done in the conditional expression itself. So here I'm saying, all right, we're going to call this function getChar. It's going to read a character off of the input stream. And while there are more characters, while it doesn't encounter a new line or end of file, it's going to keep reading and reading and reading. So we're trying to clear the input stream. The reason why we do that So let's not do that. We'll just do a scanf there. And for now, I'll just comment this out. So this works fine if I type in integers. If I type in a letter, for example, it goes into an infinite loop. And the reason for that, we've talked about this already, but just to reiterate, the reason for that is that I'm asking scanf to read an integer from the user. Scanf tries to read an integer and encounters, oh, the user typed A. So it leaves that A on the input stream, and it returns back saying, I wasn't able to match any of what you asked me to match. I wasn't able to match %d, so it returns 0. What happens is then we loop back around and we call scanf again. A is still on the input stream, so it tries to read an integer again. Once again, it can't do it, so it leaves it on the input stream, and we just go in this infinite loop where we keep trying to read from the input stream, and we keep leaving that invalid input on the stream. So what we're doing in this program by calling this clear input stream is making sure that if the user put in some invalid input, we're making sure we clear it from the input stream by calling getChar over and over and over again until that input stream is clear. So that, yeah, just an example of a case where we have a while loop where we don't actually do any useful work in the body. I just have a semicolon. All of the work is being done in the conditional expression itself. Okay, so the rest of it is pretty straightforward. We just have an if, else if kind of thing where we say, all right, if the user's guess is less than the number that the computer generated, we print higher. If it's greater, we print lower. And if it's equal, then we'll use a break to break out of our infinite loop. Okay, and so just sample invocation here, because we have that clear input stream function, if I enter invalid input like A, it's not going to go into that infinite loop. It just clears it and it re-prompts me. I type 50, it says higher, I type 75 higher, and then finally I get it, and it breaks out of the loop and the program exits. So the switch statement, again, you've probably seen this in Java. So it's just a way to more succinctly do like an if, else kind of structure. So rather than having this big chain of if, else if, and so on, we can do it more succinctly using switch. So the generic form, we are going to have some sort of expression, and then based on the value of that expression, we're going to jump to one of the cases. Now, these cases have to be constant expressions. They have to be evaluatable at compile time. You cannot have a case that, is based on a variable. So I can't say like case X. It has to be either a literal or a constant or whatever. So we evaluate the value of the expression. We jump to the corresponding case. If no case matches and there is a default statement, then we execute those statements. Otherwise, if one of the cases match, we execute those statements, and we keep executing until we hit either a break, a return, or a go-to statement. So if you do not put a break in here, execution will fall through to the next case, and then it will execute those statements as well. That can sometimes be useful. Sometimes you want that. Most times you didn't mean to omit the break, and that's a bug. So just pay attention to that. Make sure that you're putting breaks under all of your cases. Okay, so just an example here to demonstrate the difference between switch and if, else if. So exact same functionality here. The switch is just able to do it a little bit more succinctly. So we prompt the user for a choice, we switch based on their choice, and then if they enter 1, we call open file, we break. If they enter 2, we call save file, break. If they enter 3 to quit, we return 0, and then otherwise, if they entered some invalid value, we, for whatever reason, return 1. And same thing over here, exact same functionality, it's just a little bit wordier, a little bit more verbose. Okay, and then finally we have the go-to statement, the evil go-to statement. So this is considered to be like a code smell. It's not something you should be using in your code. If you find yourself using it, you probably need to reevaluate what you're doing. It's just not considered to be good practice. So it is used to jump to a labeled part of your code. So I can have any label I want as long as it's a valid identifier. I can have a label with a colon after it, and then I can say go to that label. Now the reason why it's considered to be bad practice is that it leads to spaghetti code that's really hard to read, it's hard to debug, it's hard to maintain, because in the past you had people writing all these go-to statements. The flow of control is just going all around the program, and they called it spaghetti code because of that. So it's just not a good thing to use. If you do end up using it, you should not jump backwards. It makes it harder to follow. You should never jump into a loop. The loop variables might not have been initialized at that point, so you may end up in an infinite loop. It's just, don't use it. And certainly not in CS2211, don't use goto. We mention it because you might see it in some code, but you should avoid using it. Now, one place where it is sort of semi-acceptable to use it is when you have deeply nested loops. So here we've got an infinite for loop, we've got some sort of nested while loop, and then we have a switch statement within that. And based on some case, we're going to say, okay, we want to get out of all of these loops. So we're going to go to don't do this in CS2211, and that will then jump us out of those nested loops, and we are now out of the loop. So that's sort of semi-acceptable, but just don't do that. If you find yourself using deeply nested loops like this, it maybe suggests that you need to simplify your code a bit, maybe refactor it a bit, maybe take like complex sections and modularize them into functions. Yeah, it's just, if you find yourself needing goto, you probably need to rework your code a little bit. Okay, so wrapping up this topic, compound statement, again, it's just a bunch of statements in braces. We saw the if statement. It differs from Java in that instead of executing the body if the result or the condition is true, we do it if the condition is non-zero. For statement, pre-tested loop, executed 0 or more times, again, if the condition is non-zero. While statement, same thing. We can rewrite a for loop as a while statement and vice versa. And then, of course, do while is a post-tested loop executed 1 or more times. So it's very useful when we need to, say, print a menu and prompt a user, and we want to make sure that happens at least once. And then if they enter invalid input, we keep looping, otherwise we fall out of the loop. Break, again, used to exit from a loop immediately, whereas continue is used to immediately skip to the next iteration of the loop. Switch is just simply used to replace if-else-if statements in a more succinct way. And then, of course, we saw goto to jump to a labeled section of code, and we should avoid using it. Any questions before we move on?